Okay, session B. I said session 3 earlier. Session B, ensuring reliable power delivery. We're going to skip the first presentation. We're going to go to the second one, the challenges of performing quality source inspections on international suppliers. We've got 3 speakers that are going to talk. The first one being Clinton Char from Southern California Edison. The second being Mike Patasciotto with Bureau of Veritas. And third we have is AJ Blick from Sandpack. So if you please give a warm welcome for these 3 gentlemen.
Okay, good morning. My name is Clinton Char, and I guess one good thing about being the only presentation before lunch is that right after us is lunch. The bad thing is we got more time, so yes. Our topic today is entitled The Challenges of Performing Quality Source Inspections on International Suppliers. And what we want to do in our presentation today is to basically stress the importance of having a good source inspection program to make sure that the materials that you buy for your transmission line project is delivered in a high quality. And what we want to try to do is we want to try to give you some important details as far as what you should look for when you start that program. The agenda that we're going to follow is I'm going to talk about source inspections and the TRTP project. Actually, Edison's TACHP Renewable Transmission Project, TRTP, is basically the project that we used to come up with our presentation. So this is kind of like a lessons learned as far as what we learned through the TRTP project. Then Mike is going to talk about the need for source inspection planning, execution plan for lattice steel towers, and AJ will cover the last 4 topics, the execution plan for tubeless steel poles, source inspection closeout, conclusions, and any questions. So what is source inspection, material source inspection? Material source inspection is a process of inspecting material for quality, quantity, and adherence to client specifications at the fabricator's facilities. In other words, what we want to do with material source inspections is to try to head off any problems with the materials at the facilities where the fabricator is fabricating them. And the reason for that is that if you do find any deviations, they can quickly be corrected and delivered in good condition to the field. If the materials were not found, if the defective materials were delivered to your staging areas with defects, the utility would have a lot more effort and time to resolve those issues. So what we want to try to do is we want to try to head it off at the pass and do the inspections at the facility of the fabricator. So the benefits of the program are 5-fold. First of all, it ensures that all parties understand the order requirements at the start of fabrication, so there's no questions as far as what is ordered and what's going to be delivered. We want to verify the supplier's intentions to meet the order requirements. In other words, does he have the materials? Does he have the labor involved to deliver the materials on time? We want to verify the supplier's quality control. In other words, does he have a good quality control program internally to make sure that he can deliver quality products? We want to resolve any discrepancies or deviations from the material specifications. And also, by having a source inspection, we'll have an independent determination whether the materials are delivered conforming to the specifications or whether they'll be not conforming to the specifications. To give a little bit background on the TRTP project, the TRTP project is basically, as Andy had brought up earlier, it's Edison's first big project where we're trying to bring renewable energy generated north of the Los Angeles basin into the Los Angeles area. The project was about 250 miles of transmission lines, both 220 and 500 kV. And basically it is a vital project to meet our energy renewable goal of 33% by 2020. This is a map. The wind area up here is TACHP. This is where the wind farms are located. And basically the project is to bring the energy down into the Los Angeles area, which is here. When the project is completed within about 1.5 years, It's going to be capable of bringing in about 4,500 megawatts. Now, a project of this magnitude, there's a lot of materials that need to be ordered. So these are the numbers that we have. We have about 662 lattice towers, roughly representing about 40 million pounds of steel. We have 96 tubular steel poles, about 6.7 million feet of ACSR conductor. We have a lot of OPGW, overhead ground wire, 9,800 dampers, about 19,000 insulators. All total, we spent about $100 million on materials. These are some of the suppliers and their locations of where the materials came from. We have a lot of areas in the United States. We have all the towers were fabricated in Mexico, out of 4 companies in Mexico. We had some testing done in China for our tubular steel poles. And we had some testing done at Kinetrix up in Canada. So it's basically worldwide is where we got the materials. This is a map showing where our material locations were. And China. Now the problem that we had with that large of materials and with worldwide fabricators is we didn't have the staffing involved to do adequate source inspections. So that's why Mike will take the presentation right here.
Thanks, Glenn. Can everyone hear me okay? Yeah, click. Thank you very much. The need for source inspection, with a project of this magnitude, Edison had a small in-house inspection department. So they contracted Bureau Veritas to perform source inspections. We are a worldwide organization. We've been established since 1828. We have over 63,000 employees in 140 countries. So we have a very good global footprint, and we're able to take this on behalf of Southern California Edison. As we planned it, the source inspection was to be a collaborative effort with the suppliers, and our inspectors were to work with the suppliers' QA/QC people to make sure that the quality product was being delivered. In practice, what we found was U.S. suppliers have high-quality QA/QC programs. We do inspections performed on a random spot check basis. Non-U.S. suppliers we found were below Edison's expectations. We had to embed inspectors into the supplier's daily operations, from the fabrication, material receipt, fabrication, through the galvanizing process, through the dulling process, bundling, shipping, and to reach its final destination in California. Inspectors covered most work shifts in every phase of fabrication. Challenges we had with international suppliers was the communication and the language differences. We had to make sure we had personnel that were bilingual. Different time zones. For example, to work in China, it takes you 24 hours before you get the results of those inspections back. So we had to adapt to that. Different levels of acceptable quality between the suppliers and their customers. What's acceptable for some non-U.S. suppliers, their clients, may not be acceptable to Edison, Edison's requirements being more stringent. Cultural differences, adapt to the work hours, work practices, work methods, their holiday and vacation schedule. Safety was also a large concern. There were some locations where we went to that was on the State Department's list of travel advisories. So we had one supplier where we had to totally adapt our inspection methods because we couldn't send an inspector to that facility due to the risk in the area. So instead of going in and performing inspections side by side with their QA, we had to basically go and wait for the material to be received at the main supplier's facility and do our inspections at that time. The risk there is if there's errors, then it's delays to fixing them rather than finding those errors in the fabrication process itself. A large success of the project was in the planning. So with these challenges, we decided we're going to put a plan together how we're going to address these. Prefabrication meeting was a key issue. We sat down, we reviewed the purchase order requirements, we reviewed each page of the specification, We went through any exceptions, any changes that needed to be made. We had representatives from the supplier, we had representatives from Edison Engineering. It really worked out well to make sure at the kickoff of the assignment, everyone's on the same page. The project manager, they requested one focal point of contact at the supplier, so you're getting the information through that one point. You're not calling different departments for that information. This project manager had to be bilingual. Many of us in the U.S. only speak one language, so familiar with all phases of fabrication, so they can assist in troubleshooting and resolving the issues that arise. Lead inspector, representative Edison. He's Edison himself when he walks through the doors. Bilingual, he's familiar with specs and fabrication methods, highly experienced personnel. He coordinates all the inspectors' field activities daily and communicates weekly. He can even communicate via email, phone call, if an issue arises. We took a look at the supplier's QA/QC program. We verified that it aligned to the customer's expectations. We made sure that materials conform to the spec requirements, test procedures. We also were in the process of witnessing additional testing just to make sure that material met the spec requirements. We would verify the certification of all specialized workers, welders. We make sure that their welding certs were up to date, NDT certs up to date. Facility access is very important. We need access to all parts of the supplier's facility to inspect at all phases of fabrication. The supplier needs to ensure also that we have access provided to their sub-suppliers. During the project, we had weekly telephone conferences between the project manager, lead inspector, and the customer. We talked weekly of what the actual status of work was. We discussed any engineering and manufacturing issues that arose. We reviewed the project schedule and deliveries, and we were able to develop a recovery plan when the schedule was delayed. On structure drawings, what we did is we verified that the latest drawings, approved drawings, were being used. We verified that the suppliers, customer, and the inspectors are using the same versions. What we actually did was went in and about once a month we would do an audit. We would have our list of drawings that are approved from the client. We compare them to the versions on the shop floor to make sure that no misfabrication due to drawings would occur. The steel, the supplier was able to provide the source of the raw materials and mill test reports. We also witnessed additional sharpening testing just to make sure material was ductile and met the spec requirements. Materials greater than a ½ inch thick, holes were to be drilled and plates were to be cut. Silicon and phosphorus content, low silicon steel is the best to ensure a good galvanizing surface. The doubling of galvanizing was done with the zinc phosphate process. A lot of time was involved in the dulling process, so that was a key point in making sure that this project moves smoothly. Sub-suppliers. Oftentimes they would use a sub-supplier that is known to them but was not approved by Edison. So each sub-supplier had to be qualified, had to be approved by the customer. How you can do that is by going in and doing a snapshot. One day it's what we call supplier technical audit. We go in and get a snapshot of what the shop load is like, what their quality is like, in just a one-day time frame to make sure that that supplier will be able to meet that order. They need to follow the identical QA/Q standards as supplier. We also found in many cases the information from the main supplier didn't flow down to the sub-supplier. So the sub-supplier was performing per industry standard and not Edison specification standards or requirements. Bolt holes were to be drilled, punched in correct size and proper location within proper tolerances. We use go, no-go gauges to check hole sizes actually before and after galvanizing. We also use templates to lay out each individual pieces to make sure that they were correct. Check to ensure the holes were cylindrical, perpendicular to the material surface. Welding, we make sure that all welding was performed by certified welders. Welds were UT tested. A very valuable thing that was done was prototype inspection. When a new design of a tower was submitted by Edison, the supplier would build the first tower, and we would go and spend probably 1 to 2 weeks making sure that everything was put together. It was done in a horizontal position. It was done with all bolts in place, all tightened. They were all tightened, excuse me. Then we generated 3 fit-up reports. We identified where bolts needed to be shortened, where pieces needed to be modified, and where drawings needed to be changed. Once we have those engineering review and those pieces were then approved, they were re-input into the CNC machine for production. Prototyping for the tower, it was a one-time option. It need not be performed again unless the design changes. Bundling inspection, we probably focused a good amount of time on bundling. At the beginning of the project, we had over 1,500 non-conformances in the yard based on bundling. After we put additional focus, additional inspectors on each shift, by the end of the project, we had that down to less than 80. So inspectors need to verify that the correct pieces are in the proper bundles, the bundle geography is correct, spacers are placed between to prevent the white rust. They're strapped to ensure the bundle will not break apart during shipment. The specification called for a certain number of straps, certain number of wire strands. We wanted to make sure that's being performed. Proper tags needed to be used. Early on, we had a problem with tags not arriving at the material yard, so we made sure that they were fixed, they stayed on, and recently we learned to use UV-proof markers and tags because as they sit in the material yard over time, the sun faded the tags and it was a little bit difficult. Prep for shipment. Bundles are secured on the trucks to make sure that there's minimize the damage. Proper dunnage is used to separate the bundles and make sure that that load is protected due to the roadways, the movement of the truck. Shipping, supplier provided the customer procedures to meet the U.S. Customs requirements. Upon entering the U.S., we had suppliers where the trucks were too heavy to meet the U.S. highway requirements. They actually went to a separate yard. The bundles were offloaded and then reloaded onto trucks to enter the U.S. and enter the California material yards. And I'm going to turn this over to AJ on the execution plan for tubular steel coils.
Can you hear me? Okay. Let's discuss about the execution plan for tubular poles. As most of you know here, they love poles than a lattice tower, but it's 2 different animals here we're dealing with. In a steel pole business, one of the key part is the material and the welding, and we'll go through all the process. First one, the material. As we know that we have ASTM standard, and we have to make sure that the ASTM, all the steel meets the ASTM requirement. A lot of times the challenge is happening that if you go international, like China or some part, they'll give you a Q spec, which is not exactly like ASTM, but you want to make sure that it has the same characteristic that ASTM requires for. Another thing we always face challenges is that if you have a ASTM, if you have a coil material, you make sure that after decoiling, you test it again. Sometimes you may have a variation of mechanical property if you test it after decoiling. So a lot of times the suppliers get oversight and don't pay attention to that. Just make sure that you do a test MTR after decoiling. Then the next one is the base plate and flange plate. As you know, the base plate and the flange plate is very critical for foundation and transferring the load from the pole to the foundation. So one of the critical part is that check for the laminar tear. A lot of times you get the base plate, it's not 100% perfect. So you make sure that you do a UT. Normally, industry-wise, you always check along the pole wall, both sides, like 1 or 2 inches based on the customer spec, to make sure that you have no lamination or flaw. If you find the flaws, then you fix it so that you have a proper through thickness stress in the base plate. And then, of course, before you welding it, you have to clean up the area for the welding so that you don't have any kind of porosity or any kind of welding defect after galvanizing. The next important aspect is the QA/QC manual, which is very important. Sometimes the customer may have their own spec, or supplier has their own spec. The main focus is here is that the supplier needs to have a very robust QA/QC manual that controls the quality from the beginning to the end. One of the things that is needed to be that it has to be synchronized with the customer spec, making sure that the quality control the vendor has and the quality and the customer expectations should synchronize and have a common document that you have a very good quality product at the end. And the last one, and the next one is the welding. As you know, steel pole is only welding. We don't have bolts like lattice tower. but welding is one of the critical components on the steel pole. So for that, welding procedure must be in accordance with AWSD 1.1, which is the latest. And with that, I think one of the key part is that we have to have a three process. That's the WPS, which is a welding procedure, and then the PQR and WPQR. PQR stands for the Performance Qualification Record, and WPQR. Those are the critical documents that every vendor or supplier should present to the customer, making sure that what kind of procedure you have, how you qualify your inspector, and how you maintain the records. Those are the three critical to make sure that how you maintain that. Sometimes you hire a new QC person, and the training process has to go through that, and these three documents will make sure that how you train your people, and that will also lead us to the good quality product. And one of the critical also part is that preheating a process. As you know, if you have a thick base plate or a flange plate, preheating is very critical. So you need to have a good process and procedure that this preheating is done well in advance so that you can avoid any toe crack and anything after that. Some of the process that checking wise, dimensional check is very critical. If you have a pole, don't take it as a vendor that they have been doing the business. We would recommend that do a dimensional check at random, making sure that some of your distance, your electrical current aspect, and also the load transfer aspect, all the dimensional check based on the latest revised drawings. A lot of times we find is that software have different revisions versus the customer has different revisions. It has to be a very latest drawing needs to be on the software to have the same quality. The fit-up test, we also see a lot of issue with the fit-up test, like especially in the splice joint. Sometimes you have a minimum, maximum, and a design splice. We recommend that at least you do a random fit-up test in the plant to make sure that you don't have any issue in the field. Also for the arm connection, if you have critical arm connection that you need to avoid any issues, making sure that you do it sharp so that you don't have any problem there. The next one is the UT inspection. It's very critical. As you know, it's wall welding, and welding is all checked by the UT. So if you have a critical connection like a base plate, arm connection, through plate, and seam wall, you need to make sure that you thoroughly UT. Otherwise, you have a lot of surprises in the field on the galvanizing process. The next step is that galvanizing vent and the drainage hole. As you know, the AZA, American Galvanizing Association, has certain guidelines. You have to have a proper ventilation so that you proper drainage. But also, recent study, we have gone through a lot of the design aspect that do not compromise the structural performance. If you take the big cutout on the base plate, then you're compromising the stiffness of the base plate, and also you may have potential issue with the fatigue. Same with the arm bracket, that we have found that you have to have a very small cutout so that you don't compromise with the fatigue or anything on the bracket side. The next one is the post-inspection. That's also very critical to maintain the quality. So one of the things that needs to be done is that after galvanizing, check the thickness of the galvanizing, making sure that you have a proper thickness mills on the galvanizing. Sometimes you will see that if you have a reactive steel, which means like a high silicon, then you have a very high coating of the galvanizing, which may lead to maybe a slight discoloration over the time because you may not have an atelier, so you got to pay attention to how much mills you have, and then you can determine that what's your performance over the time of the base plate, of the coating of the galvanizing. The welding of the base plate, just like we talked about the base plate welding and the through bands and all those things needs to be checked, especially for the toe crack. If you have a base plate and the flange plate, it needs to be very thoroughly to avoid any toe crack. If you find any indication, you fix it, and then you do a cold spray, and then you strip the job site so that you don't have any problem there. Always we see the challenge in the coral coat thickness. A lot of times the reading gets misleading because you make sure that coral coat is in the middle of the coating, not including the galvanizing thickness, because galvanizing thickness is not part of the coral coat, so you want to make sure of that. The next one is the new steel. I'm pretty sure that a lot of customer has recently faced a challenge that now we have a forged ring, different kind of steel. It's not a ASTM steel, but it's steel, and a lot of suppliers are using it. Just want to make sure that you need to have a new process and procedure, WPS and PQR. You should not follow your regular process and procedure to avoid any problems. And then the process traveler, this is a key part of the process traveler, that a process traveler has to be properly maintained so that if something happened in the field, you can go back and track what happened to the issue, like a root cause analysis, to make sure that what was the problem and what initiated the problem. So having to have process traveler and maintaining a record is very critical for the post-analysis if you have any challenges in the future. One of the things that we also recommend to do a rejection rate analysis. A lot of times, you may have a certain rejection during the process. You make sure that all the rejection, then you take the historical data and go back and see where it's standing. Is that a lack of experience, or there's a welding problem, or what kind of issue is that? So your rejection rate data will lead back to your root cause analysis. That where is your problem like to? And the last one is the warranty. I mean, you have to look for the fine print of the warranty. A lot of times the vendor will offer 5 years of warranty, 10 years of warranty, or 2 years of warranty. You want to make sure that what warranty includes and which way to implement to your performance. Eventually, the utility customer, they own that structure, so you want to make sure that you are pretty much covered there. So this is going to close out what Clinton and Mike said. The closeout meeting is very critical. So anytime you do the inspection, this closeout has to be done in a proper way. So what the closeout reports includes the summary of number of inspections performed, the activities performed during the inspection, overall performance metrics. We got to document all those things. And then the compared actual fabrication schedule with the plan schedule to make sure that all this inspection that you have are not impacting the project schedule and has to be hand to hand with the manufacturer. And then document any issue which arose and the resolution of the issues. So sometimes during the inspection process, you may have some issues or some of the challenges that you need to discuss it and resolve it and document it to make sure that everybody on the same page. And the last one is that if you have a photograph, that's nice, because visual always is to have a very good record of this for the documentation. And also, one of the things that for the closeout report helps in a lesson learned document. So if you have a next project coming up, you can go back to that document and see that what are the things you have done and how you improve it, so that the next project in the future, you have a very good understanding that vendor has really improved, because all of it is a continuous learning curve, and this process will give a vendor to improve and to improve the quality of the product. Finally, the conclusion. Conclusion is a well-managed resource inspection program is necessary to ensure that quality materials are produced and delivered to a project in a timely manner. That's the objective that Clinton started saying, that they have to have a good, proper, and well-advanced planning is very critical for the source inspection. So if there is any material deficiency or identified on the supplier facility, then correct it to a shipment so that you don't have to deal with the rework or any kind of delay on the job site. It helps minimizing project construction delay due to the construction issue, due to the material issues, and also it avoids potential impact of financing costs. As you know, you don't want to have any kind of material issue in the field because you have a downtime with the contractors and other things you got to deal with. So you got to make sure that this is already taken care of. And then it minimizes the cost of maintenance after the warranty, because eventually you're going to own the line. So if you have these source inspections done right way, you have at least peace of mind that it will perform in a good run. And this next one is that because the worldwide process, the worldwide vendors, there are a lot of challenges that issue needs to be considered. For example, differences in languages. Make sure that, like in Spanish, you go to Mexico, other part, you have to have flexibility in that. Then acceptable quality level. If every manufacturer have different level of quality, you got to make sure that how you incorporate in a customer quality and find a common goal. And then differences in practices and procedure, that's also critical. And then in the culture, you may have different culture and also the time and vacation and all those things comes into play. And finally, with a careful planning, execution, and good inspector, material from international supplier can be delivered on time and a level of quality. So if you have everything considered from the beginning, then you have a very quality product. And last slide is my best slide. This is one of my best slides. So I'm going to talk about some of the myths of source inspection. We always hear that, well, if you have a source inspection, then it costs money. Well, serious costs money, but you got to make a charge that you have to pay all your downtime later on, or you're going to pay upfront to take care of that. So what we recommend is that cost can be easily justified against the rework and delay in the project schedule. So you got to make sure that, yes, upfront cost, but later on it pays off. Then the second myth that we always hear is that causing delay in delivery schedule, which is not true, because when we do a source inspection, you plan in advance, and you work hand to hand with the supplier to make sure that the projects meet the customer specification, and you supply all the documents so that everything is done right. The key part is that work in advance and work in a planned way so that everything per the schedule. So it's a win-win situation for both. So if the vendor improves, the quality get improved, and the customer get the right product, so you avoid all the downtime in the labs. The next one is the experienced supplier. We always hear that, well, this vendor have, the supplier been in business last 40 years, why you need this inspection? But as you know, sometimes the increasing demand or work capacity, and you have a situation that you hire people, you have a new manpower and stuff, and there's no proper training. There's always a human errors involved. And those human errors involved gets reflected in the job site, and then you have a consequence to deal with. So we recommend that source inspection service become increasingly critical to assure of on-time delivery of properly specified transmission structure and its components. So it's always a challenge that, well, we've been in the business, we know what we're doing, but there's a second eye to look at it to make sure that those things are taken care of in the end. And finally, the last one is that, well, we always hear in the warranty. Well, customer said, I know this, supplier said, I know this business, I'll give you 5 or 10 years of warranty. Is that good? It's just on the paper? Okay, you never know tomorrow the business is going to be closed, or the business is going to be out of change the company, or what happened. But as utility, you own the product, you know that this paper doesn't good for anything. So I think the bottom line is that a source inspection is a way to go and making sure that you have a right product and the right quality, and you avoid all your downtime and your delay and the consequence of the job site. This concludes the presentation, so we're ready for the questions.
Yeah, please.
It sounds like Bureau Veritas basically operates under ISO 17020 as an audit firm, and the testing was done under ISO 17025. Can you comment on those two questions?
As far as auditing, you're talking the source inspector, or you're talking, there's two different things in my view. We handle the source inspection based on Edison type requirements. As far as auditing goes, you're talking more of a certification type auditing?
Paperwork, continuity,
Right.
supply,
That wasn't
quality
done
materials.
so much. It was more making sure that the supplier was working to their predisposed quality system.
And on the testing, was the testing done under ISO 17025?
Now, the testing was done in accordance to the Edison specification requirements, which called out the relevant codes. Anyone else? Let's start to see.
Basically, some of the specifications themselves are at fault too. They've been carried for many, many years, 20 years, 30 years.
Right.
This type of steel that is being used today is not the same thing. Or the coating, they specify like 8 mils per year, 8 mils for the core, and the question is, when you see those type of things, what do you do? The spec itself is at fault.
Right. What we do is, this is where the lessons learned document comes into play. Very crucial piece of information, because as people retire, that knowledge disappears from the company. We take that lessons learned information, it goes back to the engineering department, and that information is updated in the specifications, so it's captured and as a continual improvement process.
I mean, I'm just going to add one comment. That's like, reactive, non-reactive steel. That's the guideline is that when you buy the next time, buying an ASTM, say, give me ASTM grade 65, but you got to have other filter, your carbon, your silicon, your phosphorus, and a couple of more things that you control it. Otherwise, like for example, maximum tensile. You need to have, you don't want to give them a maximum tensile as for ASTM. You need to control it, 65, 80, 85. You don't go 100 because now you're going to the brittle because of the nature of the steel. So when you specify the steel, you need to have extra things that you put in your specification so that it will restrict some of the things that you have in STU. So that minimizes that.
Anything else? One more?
Yes.
What's an appropriate range for the cost budget for this service?
They say 1% of the total project budget is a good rule of thumb, and that can be tailored depending on the situation, how much or how little inspection is needed. That's where we like to sit down with the client and tailor-make our inspection programs to meet their needs. And That's the.
You said 1% total project cost, not 1% of material cost?
No, 1% of total project cost is the rule of thumb.
Anything else? Okay, we'll bring this session to a close. Thank you very much.
Thank you.